All right, so at example 13, we're going to start talking about rationalizing the denominator. Now, essentially, in this case, to rationalize the denominator, what we'll do is we multiply the numerator. Sorry, first, rationalizing the denominator means making the denominator rational. Essentially, that's what it's saying. Getting the denominator to become rational. Now, if you multiply a third by itself, it will become rational. We showed us already that root x times root x is actually equal to x. And so root 5 times root 5 would be equal to 5. So in a case like this, to rationalize, we simply multiply the numerator and the denominator by whatever is in the denominator. So I'm going to multiply the numerator and the denominator by root 5. And of course, in the numerator, I'm going to have 4 root 5. And in the denominator, we have root 5 times root 5, which is 5. Please do examples 14, 15, 16, 17, 18, 19, and 20. All right, so example 14 is asking us to rationalize 2 over the root of x. So to rationalize mean we want to make, I think it's rationalize the denominator. We want to make the denominator rational. In this case, we're going to multiply the numerator and the denominator by the root of x. When we do, we're going to end up with at the numerator 2 root x, and in the denominator, we're going to have x. All right, example 15. Now we're to rationalize the denominator. In this case, we have 1 over root 2 plus 3. That's a sum. You're going to multiply in a case like this where there's a sum or difference in the denominator. You're going to multiply the numerator and the denominator by the conjugate of the denominator. And the conjugate of root 2 plus 3 is root 2 minus 3. So I multiply the numerator and the denominator by the conjugate of the denominator. So up top, I'm going to have root 2 minus 3. Down by the bottom, I'm going to have 2 root 2 square, which is 2, minus 3 square, which is 9. So I'm going to end up with what? Root 2 minus 3 over minus 7. And if I just write that differently, or if I multiply both the numerator and the denominator by minus 1, I'm going to end up with 3 minus root 2 over 7. Example 16. We're to rationalize the denominator. We have 4 over 1 minus root 3. So as in the case before, we're going to multiply the numerator and the denominator by the conjugate of the denominator. So up top, I'm going to get 4 times 1 plus root 3. And in the denominator, I'm going to have 1 square minus root 3 square, which is 3. So it's 1 minus 3. This is 4, 1 plus root 3 over minus 2. So my final answer is minus 2 into 1 plus root 3. So a positive divided by a negative is a negative, and 4 divided by 2 is 2. 17. We have 2 plus root 2 over 3 minus root 2. We're to rationalize the denominator. Again, in this case, we're going to multiply the numerator and the denominator by the conjugate of the denominator. Up top, 3 plus the root of 2. So on the top, let's multiply the binomials. 2 times 3 is 6. 2 times root 2 is 2 root 2. 3 root 2 times 3 is 3 root 2. And root 2 times root 2 is 2. In the denominator, we're multiplying conjugate surds. So the answer is going to be 3 squared, which is 9, minus root 2 squared, which is 2. So what I have in the numerator is 6 plus 2 is 8. 2 root 2 plus 3 root 2 is 5 root 2. And this is over 7. Turning the page. Example 19, 18 first. We're rationalizing the denominator of 1 over 1 plus root x. I'm going to multiply the numerator and the denominator by the conjugate of the denominator. Of course, I'm going to end up at the top with 1 minus root x. And in the bottom, I'm going to end up with 1 minus x. So it's 1 squared minus root x squared. And of course, root x squared is just x. So it's 1 minus the root of x over 1 minus x. 19. We're to rationalize the denominator of 2 over 1 minus the root of x plus 1. I'm going to multiply by the numerator and the denominator by the conjugate of the denominator. So it's going to be 1 plus the root of x plus 1, plus the root of x plus 1. Up top, I'm going to have 2 into 1 plus the root of x plus 1. And down by the bottom, I'm going to have 1 squared, which is 1, minus the root of x plus 1 squared. The root of x plus 1 times the root of x plus 1, which is x plus 1. Up top, 2 into 1 plus the root of x plus 1. Down by the bottom, removing the bracket, I have 1 minus x minus 1. And so the final answer is 2 into 1 plus the root of x plus 1 divided by x. Because 1 minus 1 will be 0. So all that remains in the denominator is just x. Example 20. And after example 20, to concretize your understanding of this topic, you should do exercise 5B. So example 20A is asking us to rationalize 2 minus the root of x over 2 plus 3 root x. And of course, to rationalize the denominator, I'm going to multiply the numerator and the denominator by the conjugate of the denominator, which is 2 minus 3 root x. Multiplying, we'll end up with, up top, 2 2s are 4. 2 times minus 3 root x is minus 6 root x. Minus root x times 2 is minus 2 root x. And of course, negative times a negative is a positive. 3 root x times root x is x. And this is over 2 squared, which is 4, minus 3 root x squared, which is 9x. So this is going to work out at the top to be 4 minus 8 root x plus 3x. And at the bottom, I'm going to end up with just 4 minus 9x. Turning the page. The B part of the question is asking us to show that if we multiply 2 minus root x over 2 plus 3 root x by 4 minus x, we're going to end up with, well, I think when we multiplied this a while ago, when we rationalize the denominator, we ended up with, let's have a look, 4 minus 8 root x plus 2 plus 3x. I think it was 4 minus 8 root x plus 3x. 4 minus 8 root x plus 3x over 4 minus 9x. And we're to multiply this by what? 4 minus 9x. So the numerator and the denominator of both fractions are the same, so they can cancel out each other. And we're left with 4 minus 8 root x plus 3 x over 1 multiplied by 1, which is still just 4 minus 8 root x plus 3x. So we're asked to show that the root of the root 2 minus root x divided by 2 plus 3 root x multiplied by 4 minus 9x is equal to 4 minus 8x plus 3x, and we did that.